Hello everyone. We are going to see what are the conditions for interference of light wave. Here in this topic we will see two type of conditions. These two type of in condition, one is compulsory condition, another is optional condition. So let us see what are the compulsory condition and what are the optional condition. See here in this compulsory condition that let us see Young's double slit experiment. In this Young double slit experiment, here is obstacle, main source of monochromatic light is kept behind. Let one straight line passing through it, and here consider position of screen, and another obstacle is kept some distance away from it, and two narrow hole is made here in it. Two narrow slits, two virtual sources. It's behave like this: two virtual sources, and distance between both virtual sources is denoted by letter 2D. Two light wave emitting from beam of light from these two virtual sources here at the screen at point P, where phenomena of interference pattern is waved through the telescope here. Let capital D denotes distance between these two virtual source in case of Young's double slit experiment and screen. See here in it. So see by this diagram what are the compulsory condition and what are the optional. The compulsory conditions is that the first one, the both sources must have same frequency. If same monochromatic light their virtual sources, so both have a same frequency. So the first condition, the both virtual sources should have emit same frequency. So in this diagram it is given clearly. So let us see the first condition of it. The waves emitted by two sources must have, see this is in the box, same frequency, and this same frequency here produces by two sources. If two sources here which producing two beam of waves here, they both have really constant phase difference. Phase difference with respect to time. This is the compulsory condition for both rays, and it is given here as a second condition. What is that? The two sources must have constant phase difference with respect to time. If these two sources under this condition is known as coherent sources. So same frequency and coherent source, this both is compulsory condition to produce phenomena of interference pattern. Now for good interference, there must be some optional that the bright fringes and dark fringes appears in the field of view on the screen clearly. For this, see carefully in this fringe width which is denoted by beta is given by lambda d capital D by 2d. So fringe width beta is inversely proportional to 2d. So if we want to see good interference fringes, so it is needed to a good width on that. So for that it must to keep minimum distance between two virtual sources. So we may say that the distance between two virtual sources 2d. See the third condition. This is 2d. Should be as small as possible in the experiment. This distance must keep as minimum as possible. This is the third condition, but first optional condition here in this case. Now, see here in this formula, the fringe width beta is directly proportional to capital D here, large D, large width. But when we are keeping too much away, the intensity of the fringes will be very small. So capital D we must keep large, but sufficient large in such a way that fringes formed on the screen should be proper intensity. That here is the fourth condition. What is the fourth condition? The distance between coherent source and screen, it is denoted by capital D, should be sufficient large. Clear? Now, one more thing. See here. The fringes formed in constructive interference, it has a maximum intensity and it is given by A1 plus A2 whole square, and destructive interference there is a minimum intensity, it is A1 minus A2 whole square. So dark fringes should, if we want to see clearly dark, absolutely completely dark, and it is maximum intensity, so we may keep, if A1 is equal to A2, so A1 minus A2 becomes 0. In that condition, the dark fringe, that is the destructive interference, becomes completely 0. So it becomes very good to see and very easy to recognize the fringes. So this is the fifth condition, but it is third optional condition. The amplitude of interfering wave should be equal, means A1, if we keep A2, we can get good interference fringes. And now last, the slit of both virtual sources should be very thin, like this very pencil beam of light, monochromatic light emits from both sources for good interference pattern here. So the last one is the two sources should be quite narrow. Here in this, see, 6th, 5th, 3rd, 4th, 5th and 6th. These all are optional condition and first and second is a compulsory. So these total 6 conditions required here for a good interference pattern in case of any type of experiment. So this is for the topic. Thank you and have a nice day.